Welcome to qnawire.
In beta decay, a radioactive isotope produces a beta particle. A beta particle is symbolized E0 -1, and it's a product. In electron capture, a beta particle is also involved, but it's a reactant. So if we have an isotope that undergoes beta decay, it will produce the beta particle plus another product. To find what the other product is, we need to look up the atomic number of bromine on the periodic table, which is 35. And we know that the sum of the atomic numbers on the product side has to equal 35. So 35 is equal to -1 plus x, or x equals 36. If we look on the periodic table, we find the symbol for the element 36 is krypton. We can also find the mass number the same way. The mass number of the products must equal 80. Or x equals 80. So in beta decay, bromine 80 will produce krypton 80. If instead bromine undergoes electron capture, that means that it gains a beta particle to form a new product. Again, the atomic number is 35. And to find the atomic number, it's 35 plus a -1, or 34. And so we look on the periodic table for the element with atomic number 34, and that's selenium. And the mass number of my isotope is 80 plus 0, or 80. So electron capture produces the isotope selenium. Each one have a different amount of energy involved. Energy is something called the mass defect, which is the change in the mass. And we know this from the equation E equals mc squared. If we have a change in mass from one side to the other, we'll see energy either absorbed or released. And so we can find the change in mass, we can find the change in energy. The change in mass is the mass of the products minus the mass of the reactants. So for beta decay, it'll be the mass of my krypton nucleus minus the mass of the bromine nucleus. Given those values to be 79.916380 AMUs minus 79.918528 AMU. which equals negative 0.002148 AMU. When we look at electron capture, my change in mass is the mass of the product minus the mass of the reactant. Oops. The selenium. Or 79.961520 AMU minus 79.918528 AMU, or 0.042992 AMU. So in this case, in the beta reaction, beta decay, energy is released because it's a negative value. Here, where it's positive, it's absorbed. So if the question asks which is more, it's beta decay. If you want to by that, actually calculate how much energy is released, we use the relationship of 1 atomic mass unit equals 931.5 mega electron volts. So we can quantify the difference in the energy. So for beta decay, if I have 0.002148 AMU, if I multiply that by 931.5 mega electron volts, that's releasing 2 mega electron volts. For electron capture, my 0.04299 atomic mass units times 931.5 mega electron volts per atomic mass unit is 40.05 mega electron volts absorbed. So even though the number is much larger, the energy is much larger for electron because it's positive, it's not released.